Hello, my name is Robert Mitchell, and today Electropages is here in Nuremberg Embedded World 2024. Now today we are at the ADLINK booth and I'm joined by my friend Rajat, and it's great to meet you.
Same here.
Fantastic. So, without further ado, could you talk to the audience and tell them who you are and what you do?
I'm an employee in ADLINK, and today I would like to speak about EMU200 series, and I'm into a support department where I support 4 different stuff in ADLINK group. And if you come here, this is an ADLINK 200 series. It is an IoT gateway, which actually helps in power management system. And here you can see that we have a PV system where the renewable energy is stored, and this energy can be stored back into an energy system storage. And here, what we do is we collect all the data, and this data can be customized by using our software EGFlow. And once we have all the storage here, it is passed through an EMU200 series where we use a different protocol like TCP RTU such as Modbus. And once we have the data stored here, the same data can also be sent to an energy management system in cloud by using a different protocol known as MQTT. So this is a different type of setup where we use for storing energy management system. So this is a one setup, and if you come back here, this is a second setup where we use for EV charging station. Suppose we have multiple vehicles which are coming to the station to charge, and we have a smart factory where there is a lot of energy, and this energy is passed here. The main part of this EMU200 series is that once a vehicle comes in and once we have the other vehicle, we need to distribute the energy equally. So what it does is, suppose if we have like 60 kilowatt of power and it produces 30 watts for this and it distributes 30 watts for this. So the distribution of energy is pretty similar, like it's distributed equally.
Right.
So once the energy distribution is done, and this is communicated with OCPP protocol to this, and this can also be sent to a charging station management system to cloud, and all the data can be stored. And we have EGFlow software where we can monitor by using our system here. For instance, now you can see that we have almost like 32 ampere of power for charge point B. When I distribute it, you can see that it is distributed among these two equally. Like now it is almost like 26 ampere and 26 ampere for both the vehicles. So this is the use case of this device, and we have our own software EGFlow.
Fantastic. That honestly, you went straight into that. I was going to actually ask you some questions, but I'm really impressed. But I think from an overview what would you say is the biggest challenge in energy distribution? Would you say?
See, the most important thing is distributing the energy equally among all the vehicles. Suppose if we have one vehicle, it takes, if we parked it once and all the energy goes to the one vehicle, the other vehicle's charge is very less. It does not distribute equally. So the main focus of this EMU200 is to distribute the power equally among all the vehicles. So that is the one thing.
And I suppose the advantage of doing that load balancing means that does it help with things like power factor correction and stuff?
Yeah, power factor correction. Also, not only that, it also analyzes how much power is here, and it also collects the data from here, and we know that how much energy is left over here, and we can distribute it equally among the remaining vehicles. So it communicates equally through among.
And I also take it is this oriented towards renewable energies?
Yeah, renewable energy, and we can use any kind of energy. We just showed you an example of renewable energy here as a setup of solar panels here.
Yeah.
So,
and so I suppose this kind of system could be quite useful in the future when renewable energies need to store their energy, but you need to be able to distribute it efficiently. So it's not just acting as a power controller, it's also controlling how it's used as well as how it's generated.
Yeah, that's true.
And so it kind of sits in the middle.
Yeah.
So where exactly would you find such a unit? Where would you install it? How close would it be to your chargers? Would it be closer to the power generation or the distribution?
It should be closest to the power generation, or it can be closest to the distribution. But I would suggest it will be closer to the power chargers. Why? Because the main intention is to collect the data from the power chargers.
Right.
And the factories are helped to distribute the energy to the vehicles or whatever.
Oh, fantastic. So could you tell me what's going on here then?
It's a Neon 200 Ono camera, and it does this. We have many different cameras in different industries. So suppose if we are into an industry where we have lots of products on a conveyor belt, so it has to detect every particular time, and it has to mention accuracy. Suppose if we have
Oh, I see it here. We've got this thing over here. Okay.
If you see the device are not aligned correctly, then you can see that it's wrong placement there. So, and if the device is correct, then it's passed. Then it means that, okay, all the devices are correct. It actually reduces the effort of human, and it also helps in proper accuracy. There are many different applications which can be used here. So it is one of the best devices.
Okay, that's fantastic. So I suppose, oh, this is completely like integral. This is complete. So it's not just a camera. It's actually got the machine inside as well.
We have a neon Orion camera, which also has an SSD inside it. And this camera has a different lens here. And we are using here till 8 megapixel from 3, 5 and everything with a focal rate of 60, which can also increase till 120.
And so is this using machine vision to... Oh, brilliant. And I suppose something like this can help to reduce the amount of waste and the money lost when you have returns and issues with manufacturing. So even though something like this might cost money, it actually saves money.
Yeah, but it reduces lots of human errors. It reduces lots of humans' power and everything.
Fantastic, that's brilliant. Right, so if we now go over here, we have another demonstration that looks quite interesting. So I would like to ask you, what's going on here?
It's actually an ADM TGS30. And it is an all-in-one system, which is a 360-degree and a cabin ADAS solution for automotive solution. As you can see here, we have here 6 cameras. If you have a big vehicle like LKW or something, we can see here it's a front camera, it's a back camera, it's our left cameras, and it's our right cameras. What this entire system does is, whenever we have a vehicle in front, it can detect it like front collision vehicles. It can give us warnings saying that how far the vehicle is, where we need to stop, and it has also a lane detection warning. It has in data DMS, it has BHD, blind spot detections and everything. It has multiple detection things. So all these cameras are integrated to this one single device, and we also have a left and right warnings. If we are getting some warnings, it can be indicated in these 2 parts. And apart from that, we also have a cockpit camera where the driver drives it, and we have a system here which already warns in several different things, like if you are fatigued, and if you are on phone or something, or if you're smoking, if you're drinking something, it detects and it gives us warning. So it is an ADAS solution for making the drive much safer.
I think this is quite an important one actually, because the number of times even I've driven down a motorway, you don't realize you're tired. You start your eyes close a bit, and the moment you open up, it could be a whole second, and that could be the difference between a fatal crash. So I can see this kind of thing becoming very, very popular. And with this piece of hardware over here, I quite like the fact you've got this central demonstration where you can see all around. And I think in a world where bikes on the road are becoming more popular, that kind of technology is going to be very, very important. So what I'd like to ask you then is, how far away do you think we are from getting something like this into vehicles?
I don't think we are so far away. We can get it anytime soon.
You heard it here first. We can get them in today. So, I think that's going to be very important. I think in the next 5-10 years, I think cars are going to be required to have this kind of vision for that safety aspect. So I think just before we wrap up this video, I've just got one more question for you. For the viewers who are watching this podcast, if they want to get involved with ADLINK services and systems, what would you recommend they do?
They can just go to our company website and actually go to our company website, visit our website. We have so much of data information where they can contact to our sales department or a support department or anything to get in contact with us.
Fantastic. Thank you ever so much for having us today.
Thank you so much.
Thank you.